Let's take your attendance first. Eh? Okay, class. So today we're going to go back to the circular motion. We're done with the topic, but we're going to do the tutorial. We have some questions we can discuss together. Okay, the circular motion. Okay, let's go back. So if you see in the, I think in the notes, you have one document. This is one questions, list of questions we're going to discuss today. Okay, so take a piece of paper, get the working for this. Okay, I'll be discussing few. Okay, we go through one by one. Okay, so take a piece of paper, try to figure out what is the answer you think should be for these questions. We start with the first one. Okay. Okay, before that, recall back all the forces, So angular velocity is what? Angular velocity, the rate of changes of angular displacement, theta over t, 2 pi over t, and 2 pi f. Then v equals to r omega. Then centripetal acceleration is v squared over r omega squared. Then finally, you learn centripetal force, mv squared over r, mr omega squared. So these are the formulas you learn in circular motion. Okay. And we discussed a lot of different types of systems. Okay, first question, come on. Let's discuss together. Meantime, I'll be asking you some questions. So you try to give your input. Okay, the first one. A body of mass m travels constant speed in a circular path of radius r. It takes time to complete one revolution. T is the time taken to one revolution. Write down expression in terms of m, r, and t, mass, radius, and the period for the speed, the acceleration, or for the speed, acceleration, angular velocity, kinetic energy, and finally the momentum of the body. Okay, 5 quantities, right, in terms of MRT. Okay, so you only can use MRT. First, speed. Can you write speed in terms of MRT? I give you a command. 1 minute for you to think. Speed. In terms of MRT. Speed, we know from here speed is R omega. From here, we don't want omega. We are okay, but we don't want omega. We want in terms of M and T. Anybody? Speed equals to R omega. Then R omega is what? Omega, we don't want omega. We can put in terms of period, right? Omega in terms of period is what? 2 pi over T. So yes, 2 pi R over T. Is your speed. This is the answer for the speed. Pi no problem. Pi is just a number one. So 2 pi R over T is accepted. That's the answer for the speed. Okay. Can I get next? Acceleration. MR and T. Can you get acceleration in terms of MR and T? Centripetal acceleration. The acceleration stated here as the centripetal acceleration. MRT. Which formula to be used? You already know centripetal acceleration is v squared over r. You do want the v, r okay. But v you know already, right? Speed is your v, so v knows 2 pi r over t. I think can work out the acceleration, right? So what is acceleration? A is v squared over r. V is 2 pi r over t. So 2 pi r over t is your v squared. 1 over r. You have another 1 over r. Another 1 over r. They end up getting what? Expanded. So you got 4 pi squared r over t, right? R over t. R squared and r cancel up and down. So you get 4 pi squared r over t. This is your acceleration. Okay. So I give you another 1 minute. Come on. Give me the answer for angular velocity, kinetic energy, and momentum. I give you 1 minute. Think about it in terms of M, R, and T. Yeah, I tried to select one of you, but give a time. I give you 1 minute. Try to figure out the answer.
Sir.
Yep.
For A2, the exams, can they ask the questions from AS?
From AS. You mean in A2, is it?
Yeah.
A2, AS, not really. Maybe about sometimes, like for example, like work, all you learn what. So indirectly will be connected, but not entire syllabus. Like electricity, all they won't test you. Electricity, waves, all. Basically, you can what I can say. They should not test AS. Okay. But indirectly you learn, right? Like for example, here we involve work. So work you already learn in AS1. Here also they will ask find work. So that small tiny little things you have to know. Like electricity don't have nuclear. Nuclear also involve nuclear. You have to learn in A2 because A2 also got nuclear. Okay. So I can say 95% you don't need to know about AS, just about 5% little here and there, which you already learn in O levels. That part they're going to ask back in A2. Okay. Yeah. Sorry, yeah. Okay. About 95% you don't need to know.
Okay, I understand. Thank you.
But anyway, it's not going to give you any problem when you do A2. The one related to AS will be very little, which that information you should be able to know. It's not a big problem so far. Experienced by your seniors actually. Okay. Okay, we go to angular velocity. Reynolds, what do you think angular velocity should be? Omega. Angular velocity is omega, right? Can you give omega in terms of m, r, and t? What formula do you get? Reynolds, yeah? So omega is what? Reynolds not here. Omega is 2 pi ot. I think straight away you can give the answer, right? It's 2 pi ot, right? So angular velocity is 2 pi over t. Just divide by the period. Okay. Kinetic energy. Kinetic energy, what formula you can give? Ek is equals to what? Half m, but v is what? V we know is 2 pi r over t, so just substitute 2 pi r over t. 2 pi r over the period. So you get what? You get 2 cancels. So you get m pi r over, sorry, this is square one. Square. Made a mistake. Okay, simplify this, what do you get? So we get 4 pi squared r squared m over 2t, then 2 cancels, so it's become 2 pi squared r squared m over t. Okay, just deriving kinetic energy. Half mv squared, v is 2 pi r over t, so it's 4 pi squared r squared over t. Sorry, I made a mistake. T squared, t squared m over 2, so the bottom got t squared. Okay. So all of you getting this? Anybody getting a different answer? Kinetic energy? Half mv squared, v is 2 pi r over t squared, so you get this answer. Okay. Finally, momentum. Momentum. Saudi Grant momentum. Momentum. Momentum, you know, is mv, but mv is again, we know, 2 pi r over t. So 2 pi r over t. So it's actually 2 pi m r over t. Momentum. Okay, so this is all in terms of m, r, and t for these listed quantities. Okay, acceleration, angular velocity, kinetic energy, momentum, and speed. Okay. Okay, now go to the next one. Which of these quantities change during a revolution and which remains constant? Which is changing, which remains constant in one revolution? So directly they asking which is which is changing, which is changing means if it's a vector direction change, then it changes, right? Changes. Okay, which changes? Speed changes, uniform velocity, constant speed. So speed does not change, of course. Speed does not change. Okay, speed does not change. Okay, acceleration change. Jantar, acceleration change.
Yeah.
Acceleration change. Direction change. Another one, very important, angular velocity change. Angular velocity. Angular velocity, vector or scalar? Angular speed, it's not angular speed, it's angular velocity. Velocity. Angular velocity is vector. Angular velocity got two direction, clockwise direction, anti-clockwise direction. So angular velocity changes because sorry, if it go like one direction, okay, one direction, they are clockwise and anti-clockwise now. If it go just one direction, it does not change now. Okay, kinetic energy. Kinetic energy, of course, scalar quantity, does not changes. And momentum, of course, changes. Momentum as direction changes. Okay. Okay, so these are the second part. Okay, third one. On a sketch, show the direction of the acceleration and the momentum at a particular instant. Show the direction of acceleration and momentum in a particular instant, at any moment in a circular path. Show the acceleration and momentum. Okay, how to show this? Yeah. So of course you can draw a circle. So maybe you use this point. At this point, can you show where's the acceleration momentum? Of course, acceleration is towards the center. Acceleration. Let's say it's moving. Let's say it's in a clockwise direction. So at this moment, the momentum is which direction? Downwards. The momentum is downwards at this moment. One example for the last part. Okay. Okay, so this is about part A of question 1. Okay, I hope you understand part A. This is the part 3. Okay, now let's go to B. Okay, give you 1 minute. Come on, guys. Get me the answer in the bracket. Just take a piece of paper, try to calculate the answer. What is the acceleration of the moon? What is the acceleration of the moon? The moon may be considered to travel about the Earth in a circular orbit of a radius of that much, 3.82 times 10 to the power 8 meter, and possess a period of 2.36 times 10 to the power 6 second. Okay, yeah. Find the acceleration of the moon. Praveen, yeah? Praveen?
Yes, sir.
What formula do you think suitable?
I think you can use the angular velocity.
Because they want the acceleration, right?
Yeah.
They want the acceleration. So what is the acceleration formula in a circular motion?
It's
V squared over R or R omega squared, right? These two. These are the two equations. Which is more suitable, do you think, to be used to calculate the acceleration here? V squared over R or R omega squared?
V squared over R.
If you use V squared over R, do you know the V and R? R you know, but do you know the V?
Oh,
Yes.
no, I don't know.
So you can use R omega squared, right?
Yeah.
But R omega squared, R you know, omega, how do you find?
Using the 2 pi over t.
Yeah, 2 pi over t. 2 pi over t squared. Okay, good. Okay, guys, so use this formula. So centripetal acceleration is R omega squared to be used. So R 2 pi over t squared. So you should get this answer. Calculate to get the answer. .7. So R is 3.82 times 10 to the power 8. 2 pi over period. Period is 2.36 times 10 to the power 6. 2 pi over t square. You should get this acceleration. 2.7 times 10 to the power negative 3. Okay, so I hope all of you got this answer. 2.7 times 10 to the power negative 3. Just the formula needed is R omega squared. You have to be careful which one to use, V squared over R or R omega squared. If period given, R omega squared is the most suitable. Okay, next. Okay, qualitative question. I want you to, all of you to think. Okay, the following question is, why does the moon not fall and hit the earth? If the moon is accelerating towards the earth, why it does not fall down towards the earth? So I hope you understand what the question wants. Why the moon doesn't fall towards the earth? Sorry. Okay, so you have the Earth, the Moon. Moon is rotating the Earth. Then Moon found to be accelerating towards the center of the Earth, centripetal acceleration. Then why the Moon doesn't fall towards the Earth? Why it never fall towards the Earth? Who can give the answer for this? Why does the Moon not fall and hit the Earth? Anyone can give a try. Genuine? Genuine, yeah?
Because
Any idea? Maybe wrong, never mind, just give a try. What do you think? Why the Moon, although Moon is accelerating towards the center of the Earth, but towards the Earth, but why it never fall towards the Earth? So the answer given is
gravity
okay.
of the sun, maybe.
Yeah. Oh, you are relating to the sun, eh? Okay, assuming other planets' gravity doesn't affect the Moon, just the Earth. So why it doesn't fall towards the Earth? Okay, that
Has a
okay.
horizontal velocity.
There's a horizontal velocity, eh? Oh, you say the velocity which keep on makes it to move forward.
In orbit.
Okay, good. Okay, the answer given, this is something new for you. The answer given, what is the answer given is the gravitational force between the Moon and the Earth. The gravitational force between the Moon and the Earth provides the centripetal force for the Moon to go around go around the Earth. That's why it doesn't move toward doesn't fall towards the Earth. That's the answer given. The gravitational force between the Moon and the Earth provides the centripetal force for the Moon to go around the Earth. So therefore, it doesn't fall towards the Earth. So you just said the force, the gravitational force provides a centripetal force for the Earth to go around. Therefore, it won't fall down. It doesn't fall down. Doesn't go closer or doesn't go away. It will stay in that circular path. Okay. So that's the answer. So what you said? The gravitational force between the Moon and the Earth provide the centripetal force for the Moon to go around the Earth. Therefore, it does not fall towards the Earth. When anything has enough centripetal force, and when there is one force act as a centripetal force for the body will move in a circular path without getting closer towards the center or moving away from the center. The important is they must have a force provide the centripetal force. Okay, that's so in exam if they ask why it doesn't fall down, you have to tell what force contribute centripetal force. So that's the answer. Okay, so what is it? Why the Moon doesn't fall towards the Earth? So you say the gravitational force between the Moon and the Earth provide the centripetal force for the Moon to go around the Earth. Therefore, it doesn't fall down. Okay, any questions? Okay. Okay, so that's about part B. Okay, then this question, I don't think so. Currently, you are unable to do because this part is relating to gravity, which we'll be doing next topic. Next topic is about gravity, gravitational field. After we done that, we'll come back to this part to do this question. So currently, we skip this part. Just skip this part. We go to question 2. Okay. Question 2. Can I give you 1 minute? Come on. Read the question. Try to get the answer in the bracket. 2 minutes. Maybe I give you 2 minutes. Always try to draw a free body diagram. Try to write what equals to centripetal force. From there, you can get the answer. Okay. Always draw a free body diagram for the system. Write what equals to centripetal force. What forces is equals to the centripetal force. Then you can get the answer. Okay, if you remember, number 2 is actually a conical circular path. It's a conical circular path, like there is a string, a pendulum here. It had an angle from vertical, theta. They never mentioned theta, but they're asking the angle of inclination. The theta is the angle of inclination from vertical. Okay, it was the 10 kilogram mass. This is a 10 kilogram mass. It's whirled around a horizontal circle. So it was whirled in the horizontal circular path of how much? 4 meter. Radius is 4 meter by a revolving string that is inclined to the vertical. Yeah, okay. Okay, now the uniform speed of the object is 5 meter per second. Or the speed it traveling, or the V is 5 meter per second. Calculate the tension in the string. What is the tension in the string? How much is the tension in the string? So first question, what is the tension? Okay. So recall back your conical system. What equals to centripetal force? Write it down. I think from there you might can work out the tension maybe. So tension act diagonally, mg acting downwards. So you should know what equals to Fc, right? Try to get this answer, 116 Newton and 32.5. Okay, down. Sorry. Okay, so all of you got the answer, 116 Newton, 32.5. First, tension. How do you get tension? What is the two equation you can write from this conical? Okay, tension, what equals to centripetal force? What equals to mv squared over r? Recall that first. Okay, so what is equals to mv squared over r? Whatever force acting towards the center minus whatever force opposing it. What force acting towards the center? Because tension is like this and makes an angle vertically here, theta. So the force acting towards the center is the horizontal component of this tension. When you bring the tension down, you open the angle, so it's T sine theta. T sine theta acting towards the center. So what equals mv squared r? Of course, T sine theta. Okay. Is this equation is enough? Oh, we can't. We don't know the theta also. Then we have to go for. So I don't think so. This can help us to find tension because mass, 10 kilogram, speed, 5, radius, 4, but you don't know the theta. So therefore, we have to get more equations. What equation else you can get? Vertically. Vertically, the force is balanced. Force down, same as force up. So what's the equation? Force down mg. Force up is what? T cos theta. Still not possible to find the tension. Oh yeah, not possible to find the tension. So we divide both. You get tangent theta equals to v squared over rg. Okay, guys. So according to this sequence, I don't think so. You can find the tension first. You can find the angle first, then you can find the tension. I think you can get the angle first. You can get the 32.5 first. So which equation can be used to find the angle first? I think the third equation. The third equation can be used to find the angle. Tangent theta equals to v squared over rg, right? So find the theta. The second answer, 32.5. Once you got the theta, then you can use one of the equation on top. Either first one or the second one can be used to calculate your tension. Okay. Okay, those who haven't get, I give you 1 minute. Come on. Hope most of you recall back these three equations. You wrote this in your paper just now. I hopefully believe that you wrote these three equations. So angle obtained by using the third formula, and after that substitute the angle in the first or second equation to find the tension. You know the mass, you know the V, you know the R, gravity. If they never stated, always take 9.81 for our planet. Okay. Okay, 1 minute. Can be the answer. Under 16 Newton, 32.5. Equation, right? Okay, anyone got problem getting the answer for the two? Under 16 and 32.5. This is the equation, right? Use the third one to find the theta. Then use 1 or 2 to find your tension. Okay, anyone don't have still got problem? So you don't have problem, so no, everyone silent. So I believe that you understand. Okay, go to the next one. 3. Question 3. Okay, read the question 3 carefully. Get the answer for A and B and C. Two minutes for you. Draw the free body diagram. Right, what equals to centripetal force? Sometimes you need two equations, like conical, you need two equations. Centripetal force equals to what? And vertically, the force balance, another equation. Okay. Then from there, you try to evaluate. Okay, 3. Mass of 0.4 kilogram is rotated by a string at a constant speed v in a vertical circle. Or this is a vertical circle of radius 1 meter. So this is the second example, right? We did in our last time. Vertical circular motion. The tension become maximum at the bottom. The tension become minimum at the top. Okay. If the minimum tension of the string is 3 Newton. Oh, they said when you whirl it vertically up and down, the minimum tension it experiences is 3 Newton. You should know where this 3 Newton happens. Where the minimum tension happens, you should figure out at which location. At the bottom or top. You need to think about that. Of course, it's at the top, right? At the top only, minimum tension will be experienced by the system, right? Minimum tension is attained when the string is at the top. At the top here, the tension will be the minimum for sure. Okay, according to them, they say the minimum tension is 3 Newton. That means indirectly you should know that the tension when it's located at the top, the tension is 3 Newton. Okay, is 3 Newton. Okay, the minimum tell us the location. The minimum is the one tell us the location. It should be on the top. Okay. So calculate what is the speed at that moment. What speed is rotating at that moment? Okay, your answer should get 4.2 meter per second. How do you get 4.2 meter per second? Anybody? Okay. How do you get 4.2? Okay, just put it here, just for a while. Okay, we understand the system. At the top, the pendulum at the top, the tension acting down, and of course the mg also acting down. Okay, when it whirl at the top. So they're asking what speed is rotating. They're asking for the speed. Okay, so we write the formula. So what's the formula at the top? At the top, tension plus mg is mv squared over r, correct? Whatever force acting toward the center minus whatever force opposing is mv squared over r. So this is the formula must come to your mind. You're looking for the v. Okay, do you have other information so that v can be obtained? Do you know mass? Mass given, what? Mass given, radius given. So everything you know, so you can find the v. So tension is what? At the top, they say it's 3 Newton. Mass is 0.4. Gravity always take 9.81. Mass is 0.4. V is the one we are looking for. R is radius of is 1 meter. Okay, you can look up the V. So this should be your V.
Yes, sir.
Yes, sir.
So yeah.
When do you use the square root RG formula?
Square root RG. Okay, square root RG you use when V is minimum. When V is minimum, you move with the minimum speed. This V is not minimum, you know. This V is not minimum. They never said this V is minimum. They said, you know, last time when we discussed this system, you give a range of value, right? Say V minimum must be this, V maximum must be this, right? V minimum maybe 2, V maximum let's say 8. In this case, that the person whirl it with one intermediate velocity, maybe 4. I'm not sure, maybe 4. So whirling with a 4. So it has a certain tension at the top. The tension is found to be 3 Newton in this case. Okay. So when they use V minimum, V is root of RG means when the question asking for what is the V minimum required, minimum velocity required to move in a circular path, then use root of RG. Okay. Riyad, you got idea?
Yeah.
When they say what is the minimum velocity required to move in a circular path, then root of RG. Okay. But here they say tension is minimum. Of course, we know tension is minimum happens at the top. But in this case, the minimum tension can be, we know is 0, right? At the top, the T lowest can go is 0. But in this case, he is rolling it with some intermediate speed. That's why at the top, the tension still got some value, 3 Newton. Okay. So that's why we use location at the top, but T got 3. So the V we got obtained here is not actually the lowest speed, it's actually an intermediate speed, which give a tension of 3. Okay, guys, so those, when you read this question, those come up with this formula. Okay, you are correct, in the correct track, you understand, good. Then you substitute, you get the speed, should get 4.2 meter per second. Okay. So now think about B. The maximum tension. Okay, so just now you got this. Find the maximum tension. The maximum tension. Oh, at this moment. At this moment, what is the maximum tension? When you whirl it with 4.2 meter per second, how much is the maximum tension the system will attain? So again, maximum tension. Maximum tension, where maximum tension happens? At the bottom, right? At the bottom, it will attain the maximum tension. So, Ashley, yeah, Ashley. So you consider the bottom, right? Correct? To find maximum tension. When something whirl vertically up and down, the maximum tension happens, of course, at the bottom, correct? Okay, what's the equation at the bottom? What equals to mv squared over r?
T minus mg.
Very good. T minus mg is mv squared over r. Yeah, so we know T is max at the bottom. So the equation must be used is the equation at the bottom. T is up, mg is down. So T minus mg is mv squared over r. Okay, so we want to find T max and T max. So mass given, gravity given, m given, v just now we got what? The speed it was whirling was 4.2 meter per second. So you put the V as 4.2, you get the tension, which the maximum tension ever experienced in this circular path, which is at the bottom. Yeah, so make the T as the subject, you get the T max in Newton. You should get 11 Newton. Okay. Calculate, do you get 11 Newton? Okay, my important point here is you should know T max happens at the bottom. So you should get this equation, then you find the T. Those who realize you must choose the bottom point and you realize this is the equation to be used, T minus mg is mv squared R. Okay, so you are on a correct track. So you understand. Okay, those couldn't figure out the bottom is the T max and you can't figure out this equation, or then you have to, again, you need to revise back this topic, how to write the equation. Okay, I believe that nobody have this problem writing the equation. Okay, so I hope you got 11 Newton maximum. Okay, next, the tension. See, the tension when the string is just horizontal. Okay, what is the tension when it's horizontal? Okay, this is okay, right? So you consider the horizontal now, right? Okay, what is the tension when it's at horizontal? So of course, when the string is horizontal, so identify all the forces. Of course, tension down in and mg is acting down for, but mv squared over r should be equals to the tension. That's it, right? So you find the tension when it's horizontal. So mv squared over r. So mass is 0.4, v is 4.2 just now you got, and r is 1 meter. So you get 7 Newton. Okay. Any questions, guys? Number 3. Okay. Good answer. Okay, let's go a little challenging one. You can do number 4. You are quite good in circular motion. Number 4. Okay, number 4. Read the question. Try to get some idea. Try to imagine how the system looks like. Number 4. A special prototype model aeroplane. Okay. 1 minute for you to read. Try to understand the question first. Okay. Maybe I can draw for you. A special prototype model aeroplane of mass 400 gram as a control wire of 8 meter long attached to its body. The other end of the control line is attached to the fixed point. And the aeroplane flies with its wing horizontal. The wing is horizontal in a horizontal circle, making 1 revolution per second. The control wire is elevated 30 degrees above horizontal. Draw a diagram showing the forces exerted on the plane and determine the tension and the lift. On the plane. Okay, lift on the plane. Okay, I don't know. Imagine actually what system they said at the ground. It was tied to the ground. There is a string. The plane is just, the wing is horizontal in the air. Now this is ground. This is ground. Okay, so it makes a horizontal circular path in the air. Okay, but the wing is horizontal, perfectly horizontal. It tied to a string. Okay, tied to a string. And the string is how much? The string is about 8 meter long. The string is 8 meter. So this is 8 meter. Okay, this is 8 meter long. Okay, the string. Okay. And of course, the plane was 400 gram. It's a toy. 400 gram mass, the aeroplane, and makes a 30 degrees above horizontal. So from the ground, it makes a 30 degrees above horizontal. Okay, and it makes one revolution 4 seconds. One revolution, the period was 4 seconds. Okay, this is the diagram. Okay. Real examination, the diagram will be provided. That's why I'm showing the diagram. Okay, I'm showing the diagram. Okay, so this is the situation of the plane. The plane wing is horizontal. Okay. Now your turn. Think carefully. Draw a diagram showing the forces. Can you draw what are the forces exerted on the plane? Can you draw the free body diagram for the plane? And from there, can you work out how much is the tension in the wire and what is the lift force on the plane? Okay. In this case, take G as 10, take gravity as 10 meter per second squared, and pi squared is 10. Take pi squared also 10. Okay. I give you 1 minute. Those who can get 8 Newton, both without my explanation later, I consider you are good. Okay, just 1 minute, come on. Draw the free body diagram first. What are the forces acting on the plane at this moment? How many forces acting on the plane at this moment? Imagine the plane, the plane. It tied to the rope string, 8 meter long at the ground. It makes a 30 degrees from horizontal. Okay, how many force acting on the plane? Anybody? Anyone? How many force do you think acts on the plane? Tension. There are 3 forces actually acting on the plane. There are 3 forces acting on the plane. Try to identify there is 3 forces. What are the 3 forces acting on the plane? Soham, yeah? Soham? Soham? Soham Nodia. Kidan? Kidan? Kidan also Nodia. Okay, guys, you have to answer. Pranav here, Pranav?
Yeah.
So, yeah, can you tell me, can you tell what are the force acting roughly? Can give a try, wrong, never mind, just give a try. What are the force do you think acts on the plane?
Tension and gravity.
Okay, so gravitational force acting vertically down, mg. Tension acting down or up?
Upwards.
Okay, if you focus to the ground, tension
Like
acting upwards. For the plane, it's acting down, right? Tension is down. Tension for the plane, the tension is down because the rope pulling the plane down, so tension is down for the plane. Yeah, good. Okay, tension down, mg down. Another one force. Pranav?
I'm not sure.
The lift, because plane work. So lift force is always perpendicular to the wing. Wing is horizontal. Lift force will be like this, vertically up. Okay, this is different from the one earlier we discussed. The earlier one we discussed the plane, actually the wing has been tilted. So the lifted force also lifted force always 90 degrees to the wing for sure. In this case, because the wing is horizontal, so lift force is just vertically up. Okay, good. So these are the 3 force acting on the plane. Tension pulling diagonally down, weight vertically downwards, lift force is upwards. Okay. Now can you use your circular motion knowledge? Can you find the tension and the lift force now? So how are you going to find the tension, find the L, find L and T. How much? So how you can find? Write the 2 equations as usual. What equals to centripetal force? Vertically, the force must be balanced up and down. You get 2 equations. I think from there you can solve it. Okay, same technique. Okay, come on, 1 minute. Try to get 8 Newton and 8 Newton for both. Tension down, mg down, L up. Okay, what equals to centripetal force will be for this system? Okay, tension like this, mg down. Okay, from here it makes 30 degrees, vertically lifting force. Okay, it makes a circle here. Okay, so what equals to centripetal force? Mv squared over r. Whatever force acting towards the center minus whatever force opposing. What force acting towards the center? Is it L provide the centripetal force or not? L is 90 degrees towards the center, so L doesn't contribute anything. Mg also 90 degrees towards the center. The tension is diagonal, support the force towards the center. So what is that? T cos 30 or T sin 30? If this is 30, here will be 30. Up here 30, zigzag, right? 30. So T bring up towards the center. The component will be what? This component. This component. Is T cos 30 or T sin 30? It could be T cos 30, right? T cos 30. T cos 30 is mv squared over r. Okay. First equation. Okay. So this equation, can you help us to find the tension and the lifting force? Or tension we can find from here, right? Yeah, we don't know the tension. M, you know, mass. Mass, we know 400 gram. Speed involved. Do they tell you what speed is moving? Oh, they never tell speed. Never tell speed, but they give period. Because they give period, I don't think so. Mv squared r is quite suitable. What formula is the best? Because they give period, you better write mr omega squared. So mr omega squared. T cos 30 equals to mr omega squared is quite suitable compared to mv squared over r, because v not given, but period given, so we can find the omega. So from here we can work out the t. Okay. Okay, so I think you can get the t, right? Hope those who got this diagram correct, good. Okay, in exam the diagram will be given without the force, so you should know the force acting, tension downwards, mg downwards. That tension is diagonally downwards. Lifting is always perpendicular to the wing. If this diagram is good, correct, good. Now the equation do you get correctly? T cos 30 is mr omega squared. Next step, good. But then now you get the tension. How do you get the lifting force? How do you get lifting force? To get lifting force, you have to resolve vertically. Force up equals to force down. Because vertically the force is balanced. Up balanced with down. So what force up, what force down? What force acting up? The only force acting up is the lifting force. What force acting down? Mg plus another one force, the tension. The vertical component of the tension is acting down. Don't forget that. Tension acting here horizontally provide a centripetal force. The vertical component of the tension acting down. T what? T sin 30 acting down. So in this case, L equals to mg plus T sin 30. So this is another one equation. I think the second equation can help you to find the lifting force. Tension you know already. Mg all you know, so you can find the lifting force. Okay, this is the idea how do you go about with question 4. Okay, so later give a try to get the working for this. Okay, and try to make sure you get both 8 Newton, take G as 10, pi squared as 10. Okay, guys, any questions from here?
Why is it T cos theta?
Why T cos theta for mv squared over r? Okay. So I go to this diagram. So the tension is acting here, right? Horizontally is 30. So this is the circle it makes. So if I make like, maths, if this is here 30, here also will be 30, right? Okay, a parallel line. Okay, so this tension you resolve to this direction. So this is your T. Here is 30. How much this component will be? Is t sine 30 or t cos 30? It's going to be t cos 30, right? T cos 30, right? From here, what? Adjacent over the hypo. Adjacent over hypo is cos 30. Cos 30 equals to whatever we know over t. So t cos 30 is the horizontal component. Actually, you got idea?
Okay, thanks.
Okay, guys, any other questions about 4? This is a very unique one. So we thought normally the center one going to be t sine 30, but here unfortunately it's t cos 30 equals to mv squared. Wow. So you have to be careful always. Okay. So give a try this 8 Newton. Try to get these two. And as a homework, 5, 6, and 7 is going to be your homework. Give a try. Okay. The next class tomorrow, maybe for the first 5 minutes, I check with you. If you didn't get answer, then I discuss. If not, I go ahead with the next topic, gravitation. Okay. So these 3 going to be your homework. Okay. I might ask working 2 later, but try to get the working first. 5, 6, 7. We've done a lot of systems already. A lot of systems. I should be able to get the answer. I'll give a try. Okay, any questions, guys? So it's already time's up. So I stop here. Okay. Okay, thanks. Tomorrow we'll be starting with a new topic.